Good morning, everyone. Okay, my name is Hugo Gaggioni. I'm going to give you a tour of some of the new technologies and products that Sony is introducing at this NAB for the creation of HDR workflows for non-real-time as well as for real-time applications. As you probably know, Sony has classified different classes of images depending on the type of applications. We have so-called large-scale production for cinematography, for movie making, which requires very high levels of picture quality, but we have to do a lot of post-production and processing in post houses where we do non-real-time grading of the material. Another class of pictures that we have also with very complex workflows and high levels of picture quality is for live applications, for sports applications in particular. Again, the quality is very, very high, but we don't have time to do it in non-real time. It has to be done in real-time application. Another class of applications is what we call corporate video, event videography, wedding videography, where the picture quality is very high, but the levels of complexity in the workflows are not as high as what we have in the more complex, high-budget operations. For each one of these classes of applications, Sony has been introducing different kinds of products with different features, different requirements, from very high quality studio cameras, cinematographic cameras, and event videography equipment. With that experience and that know-how, Sony has defined three classes of HDR workflows or technologies. The first one is called SR Live, Scene Refer, for live applications. This is an environment which is based on 10 bits, and we will use S-Log3 and HLG Live for the HDR gammas for production. In the area of cinematography, Sony advocates the use of 16-bit linear to produce and capture the highest quality in your cinematography cameras. You do your post-production, you do your final picture, and then you apply your color grading, your HDR curve for distribution. And something we call instant HDR, which is for post-production-less type of applications. People that do not have the experience or the know-how or even the resources to go into complex workflows for HDR production. Sony has been engaging with many customers and different companies in order to satisfy the requirements and the voices of the customers in the area of the type of characteristics that these HDRs require. In the area of cinematography, with the movie studios, we know that the material has to be of very high picture quality, and we know we have to eventually distribute over-the-top applications, video on demand, or ultra high definition Blu-rays, using the PQ curve. I will explain what PQ is in a few minutes. In live applications, again, we require a very high level of picture quality in real time in the outside broadcasting trucks, knowing that we have to, once the material is produced, we have to flip it, we have to convert it to HLG or PQ for distribution to your home. And in the area of independent or small production, Sony has adopted the use of HLG, hybrid log gamma, which I will explain in a minute, for consumer as well as semi-professional applications. HDR is not only about high dynamic range, it's not about volume of brightness, but it's also for an expanded color gamut. Then there you see the traditional 709 color space and the P3 cinematic color space. The higher standard of color reproduction is the 2020. That is at the borders of the triangle that is around the edge of the spectrum, the color spectrum. And the standard dynamic range is usually 100 nits, about 150 to 100 nits, but high dynamic range can go up to 10,000 nits of brightness. There are two standards that have been created for the standardization of ultra high definition. The first one, recommendation 2020, came out about 6-7 years ago and describes the parameters of the three classes of ultra-high definition, 1080p, 4K, and 8K. The more recent one, the recommendation 2100, describes the characteristics of the two classes of curves for high dynamic range. The first one is called the PQ, perceptual quantizer. It's a curve that specifies precisely the electrical to optical transfer function, the EOTF, that is usually implemented in your TV set and the consumer display. The other characteristic, the other curve for high dynamic range production is called HLG, hybrid log gamma. It's more like a television gamma and defines the conversion from optical to electrical transfer functions, the OETF, and is usually placed in the production environment, whether it's in the camera head or in the production of the material. Let me begin with the first class of high dynamic range technologies. This is the file-based HDR production. As you probably know, Sony is very famous for producing very, very high quality cinematographic camera. And at this show, we are unveiling the Venice camera, which is our 6K full frame cinematography camcorder. We also have the F65, which is an 8K camcorder camera, and the F55 and the FS7 Mark II. These are all Super 35 millimeters, the F55 and the FS7, producing 4K content of exquisite picture quality. In all of these cameras, we record using a recorder attached to the camera, something called RAW, as well as something called XOCN, which I will explain in detail in a few minutes. Also, if you're recording in memory, in the memory it is associated with the camera, we can record in 10 bits using our compression system, the XAVC, using logarithmic curve, the S-log3. The color spectrum of these cameras is much wider than the color gamut that we have for transmission or even for processing. Therefore, the S-gamut 3, which is inherent to our sensors, is much wider than the 2020 color space, in order to be able to capture fully all of the colors of the production, and then during the post-production reduce to the delivery color spaces. Therefore, the workflow in the production of a movie, of a cinematographic piece, you have your highest quality. We advocate 16-bit linear precision. Then you do your primary grading of the process, and then you have your creative grading of the material. And then you make the decision whether your final product is an SDR or an HDR production. Most of the time, people opt to have a high dynamic range production from which we can derive a standard dynamic range production for delivery. Now let me explain the introduction of something new called the XOCN, the Extended Tonal Range Original Camera Negative. This is a new file format and algorithm especially designed for the sensors of the Venice camera and the F55, and is recorded in the R7 recorder that attaches at the back of these cameras. This algorithm is completely 16-bit linear that permits the total capture of the information from the data from the sensor, and allows us for very fine color grading capabilities, a green screen, and very high dynamic range workflow. But we also have RAW. We had RAW before. What is the difference with XOCN? XOCN standard allows us to reduce the file size by 30%, and the XOCN Lite can reduce the file size by a factor of 60%, which is very, very important for the reduction of cost during the making of the movie. Therefore, in getting into more detail, we have the image capture at 16-bit linear precision without any curve, just absolutely linear. We do our edit, our grading, our primary corrections, with compositing, and then we produce the final master of the movie in high dynamic range. It is at that point where you should apply whether it's PQ distribution or HLG distribution. But the bulk of the production should be done in linear environment with the highest levels of picture quality. Using XOCN, specifically in the area when we attach the recorder to the F55 camera, we are able to achieve 120 frames per second capture in 4K, or 240 frames per second when we are doing a 2K capture. All right, let me go into a little bit more detail on XOCN, Extended Tonal Range Original Camera Negative. Once again, this is 16-bit precision. There is no gamma applied to the format. It's exceptional quality. We sacrifice no information whatsoever from the sensor, equivalent to the RAW of the camera, but produces smaller file sizes, 30% in the case of ST, 60% in the case of LT, and maintains the robustness that we require during the post-production environment. Any algorithm for image processing that you throw at this format, it maintains the quality of the processing. The reason we introduced this format is one of cost, primarily. As you are very familiar, the RAW that we produce in the F55 camera is 943 megabits per second, which is smaller than some competing formats. But still, even with the smaller format of the RAW, the Sony RAW, is still heavy and is still costly in manipulation and in storage. When we introduce the XOCN ST and LT, again, we reduce by 60%, facilitating reducing the cost of storage, almost to the level that the file size becomes so close to the level of XAVC that we have in television work. This is a workflow chart of the operations that we have in Sony Pictures in making a movie. Then the traditional way, you have your dailies, you have your mobile hard drive to move the content left or right, you have your sharing of the material inside your buildings, you have your local intra-networks in the building, your IT switches, sometimes even cloud storage for some of the dailies. And each one of these components of the workflow has a maximum level of bit rate, bandwidth. If your format that you are processing in this workflow exceeds the capability of that component, you're going to introduce non-real time. You're going to suffer rendering delays. It may have a 1 hour of material will take multiple hours of rendering. Therefore, there is an advantage in reducing the data rate of that stream, of that format. Also, the storage cost. For example, a 1 hour of the Sony RAW of the F55 is about 424 gigabytes of storage. The XOCN standard is 300 gigabytes. Some of the formats in the industry can reach even 2.6 terabytes of storage, which will become very expensive. All right, let me just go a little bit deeper. If XOCN reduces the file size, what is the penalty? What are we missing? What are we sacrificing? Then again, the ST is 30% lower storage cost. LT is 60%. All right, I'm going to show you this picture, a capture from the original RAW from an F55. And to facilitate the examination of the picture, I'm going to go cut in. I'm going to magnify the picture by a factor of 5. And then you begin to see the pixels in the picture. This is RAW. This is XOCN ST, 30% smaller. Back. This is RAW again. This is ST. There is no discernible difference. This is LT. No difference. Let me go 10 times magnification. This is RAW. This is ST. Back to RAW. ST. This is a 30% smaller file. And this is LT. Very few changes in some of the pixels. This just amounts to a few quantization levels, but you're reducing the file size by 60%. This is a dramatic digital negative, and the ratios of reduction do not change with the variations in high frame rate. This amazing algorithm now Sony is releasing to all of the platforms in post-production, and for onset dailies and color grading. There's a number of companies that are now supporting the decoding of the XOCN files, and also the transcoding partners and nonlinear editors are now all adopting the use of XOCN. Also, Sony has some software solutions which are very powerful, and one of them, the RAW viewer, is completely free of charge, and it's an incredible grading machine capable of handling the RAW and XOCN and transcoding and converting to any of the distribution HDR functions. Okay, let me switch to another environment. This is the environment of live application. I just covered the non-real-time, non-live applications. I'm going to cover now live applications. This environment is called SR Live, Scene Refer, for live production. It means we're going to create HDR product as seen by the camera, as captured by the camera. And another very important requirement of this production, of this environment, is the simultaneous creation of SDR and an HDR. Live production people don't have the luxury, not the resources to have an SDR truck and an HDR truck. They only have one set of crew, one operating crew. But we need dual products, an SDR quality and an HDR quality product. And eventually, we have to deliver the standards that have been approved in the 2100 for consumer delivery. Then this is your truck. This is an outside broadcasting truck. The truck consists of your video switchers, your monitor walls, your servers, your special effects, your audio console. That environment is defined as 1080p or 4K. And the color space will be 2020. Sony has adopted for live productions two special master formats in HDR, S-Log3 and something we call HLG Live. All of the sources into the truck come from either our cameras, our studio cameras, which are now have become a de facto cameras in the world of live applications, the 4300. And if we have cameras, legacy cameras, we will have to help them to convert to S-Log3 or HLG Live for production. Same as computer graphics, inserts, live feeds. Once your master format in the truck is completed, your production is ready to be delivered, then we have to convert them for distribution. And then we can distribute them in HLG, in PQ, and most importantly, we cannot sacrifice the picture quality of the SDR, because this is how you make a living. The SDR quality cannot be compromised. How do we achieve this? Well, in our high-end studio cameras for live applications, the 4300, the high frame rate 4800, the POV camera, the P43, and even in our new 8K camera, these BPUs, the baseband processing units, can output simultaneously HDR, SDR, 709, 2020, 4K, HD. We have multiple engines of processing inside those BPUs. When you turn on the cameras, the HDR path and the SDR path have the equal gain. As the operator opens the iris and starts increasing the brightness of the HDR path, the pictures look very good. But then you may compromise, you're going to clip the SDR signal. It is at that point that we introduce differential gain and attenuate the value of the light going into the SDR path, so that the camera operator produces perfect SDR at 100 nits and perfect HDR within a context of 1,000 nits in the production environment. It is at that point you lock that differential gain, and the operator shakes the camera only looking at the SDR product, because that is your primary output today. At the output of the truck, we have this converter. This is a universal converter that we have been using for a number of years. It converts anything to anything. SDR to HDR, HD to 4K, 4K to HD, 709 to 2020. It used to have 2 channels of 4K. Now also it operates in 8 channels of 1080p. Therefore, you can have 8 sources that can be manipulated in gammas, input and output, as well as the resulting SDR signal. What we are announcing at the show, we support now also 12G interfaces, and it has 6 channels of audio per channel that is coming into the unit. And there is a function for add insertion called a display refer function. In the past, this unit had to be adjusted manually in a rack in the truck. That was painful. Now, this can be part of a master setup unit that controls all of the cameras. Therefore, one single operator can control all of the cameras of the truck as well as the universal converter. Therefore, this is the advantage of live workflows, the SR Live. The SDR look and the HDR look decided by the technical director of the truck can be transported all the way to your living room. The SDR is 709, the HDR is HLG or S-Log3. That look, that decision, that artistic decision can be transported all the way to the living room. This is called artistic intent render. Okay? It has some mathematics around it, but I'm not going to talk about it. But it's the first time in the industry that we guarantee that the look of a production can be transmitted all the way to the end user. Therefore, this is the truck again. The video engineers, the technical directors adjust the gains of all of the cameras. It's working in 1080p or 4K. And this production has been tried in many, many countries around the world. And we've done many, many productions. We were very successful last year to cover the finals of the European Football League. And that gave us the rights to cover the World Cup. As some of you may know, all of the cameras in the World Cup are supplied by Sony, and all of the production in HDR is done in S-Log3, which will be converted to PQ or HLG for distribution. We have done also entertainment applications in S-Log3, as well as HLG productions, more recently the Masters here in golf tournaments in the US. We also extend this application not only to the recent cameras, the 4300 and 4800, but to legacy cameras that are very well known in the industry, like the Series 2500. These are HD cameras of very high quality, but by introducing the signal processing in that board, the 2040, which is available today, we can mimic the effects of HDR and converting the signal to 1080p or 4K at the output. This is a way to repurpose the investments of cameras in the near past. At this show, we are showing a new camcorder. You can see it in the camera set. This camcorder is a 4K camcorder that is capable of recording HDR and SDR simultaneously. The same approach that we had before. It has S-Log3 as well as HLG live curve. You can record 1080p HDR, 1080i or 720p SDR. You can do 4K HDR, HD SDR, all simultaneously, 2 files in a single memory, totally synchronized. One for your master, one for your delivery. These are our distribution, our monitoring set. You are probably very familiar with the X300, the best monitor right now for color grading and picture evaluation. This is a 4K set, but expensive. Maybe some of the truck operators may not have enough room to have this monitor. We are introducing a smaller monitor. This is a 17-inch 1080p for rack-mountable operation, but has all of the signal processing. And look, it's an OLED, it's an RGB OLED, same as what we have in the X300, but this is for the shaders in the truck. For client monitoring, we have the X550, which is a 55-inch device. All of them are shown here on the right-hand side of the booth. But this 550 the surface can be split in 4 quadrants. Each quadrant becomes an independent imaging engine. I can have 709, 2020, S-Log3, HLG, SDR, totally separated in the 4 quadrants of the display. Therefore, Sony has completed all of the devices for very high quality live production applications for real-time production. Okay? Now, to conclude, let me just say a few words in the area of instant high dynamic range. And the key is the word instant. These are people that are not perhaps too concerned about the complexities of creating HDR. Maybe they don't have the resources to do all the post-production effects to do the production of the video. Or they want to minimize the complexities of the production. For this environment, Sony is introducing HLG, Hybrid Log Gamma, one of the formats in the 2100 standard. Then we began with these 2 handy cameras, and now all of our consumer devices and the recent semi-professional cameras, the new X280 that is shown here, and the X190, all of these new handy camcorders, which are 4K capable, now contain HLG high dynamic range capability. Then it's very simple. You just press a button and you record HLG on XAVC. And it has very simple interfaces. You can do simple editing, and you rely on the HLG EOTF that is embedded in your consumer sets. Once again, just to remind you, a hybrid log gamma is a curve that writes the gamma portion of this 709 and then takes off as a log curve. What does that mean? Well, it means that if you plug HLG into a regular monitor, it produces an okay signal. It looks like a video signal. If you connect that material to a true HLG EOTF, it produces a spectacular picture. Well, we are installing in all of our consumers and semi-professional cameras 3 classes of HLGs, HLG 1, 2, and 3, depending on the amount of exposure that you want at any given time. You might be shooting indoors, where you don't need to have a 800%, 1,000% of exposure. HLG 1 will give you about 600% of exposure with very low noise. You go outdoors and it's cloudy. Maybe you need 800% of exposure. You go to the beach or a baseball game and you need maximum capability of the camcorder. We go HLG 3. Well, HLG 3 will give you the maximum response of HLG, but matches the look, not the mathematics, but the look of HLG Live that we have in the professional environment. So you can imagine you have the studio cameras operating in HLG Live, the shoulder camcorders operated in HLG Live, and you have the reporters running around shooting HLG 3. And the look of these 3 classes of material match fairly well. To hear more about the production of a HLG environment, Alistair Chapman will be giving this afternoon a detailed presentation on the post-production environment of HLG. Thank you very much.